All right, let's take a look at this hot dog example in StatCrunch. I have my two columns of data. I have the calories in one column, which is the X variable, and the sodium in another column, which is the Y variable. I can press on Stat and scroll down to Regression, and I want to go over to Simple Linear, and I need to select both the X variable and the Y variable. Okay, so my X variable was columns and my Y variable was sodium. Now this is something that's reasonably new to StatCrunch. Okay, so when I look down at Perform Hypothesis Test, I have a separate test for the intercept and a separate test for the slope. What we are concerned about in this text is testing whether or not the slope is equal to 0, and that is an equivalent test for testing whether or not rho is equal to 0. Okay, so when we're testing whether or not the slope is equal to 0, we're testing whether or not we do have a linear relationship between x and y. Okay, so I'm going to leave this as a two-tailed test, and you'll notice in your book it says that for the tests in this book, we're only doing two-tailed tests. So it's either there is no linear relationship as stated in the null, or versus there is a linear relationship. And we can tell if that linear relationship is negative or positive by looking at both the graph and the sign of the correlation coefficient. If that's negative, then we would have a negative linear relationship if we've determined that rho is significant. And if R is positive, that would mean, and also if it was significant, that would mean we would have a positive linear relationship. Okay, so I'm going to go ahead and press OK, or sorry, press Compute. Now let's take a look at the output for this. Okay, we'll see that we're going to get some information for both the intercept and the slope. Now, we're not concerned with testing the intercept whether or not it goes through 0 in this class, and for a lot of the problems that you might encounter in the future, testing the intercept isn't necessarily relevant unless you know your data set is likely to go through the origin. Okay, so we're going to ignore this part. So what you need for the homework is you need this test statistic. Okay, that's the other way to test for a linear relationship that's shown in the text. And we'll see that its corresponding p-value is 0.003, which would mean that we would reject the null hypothesis of no linear relationship at all levels of significance. Okay, so we are dealing with a strong linear relationship between x and y. Okay, so looking up at the top portion of the output, we have our correlation coefficient right here. It's about 0.91, okay, with some rounding, or 0.906 if you rounded the third decimal place. Okay, so that is a fairly large correlation coefficient. We could compare that to Table 11, find a critical value for it, or we could base our decision on the p-value from the corresponding t-test statistic. Okay, so we've determined that we do have a strong linear relationship. This correlation coefficient is positive, so that's indicative of a positive linear relationship. And here's the corresponding regression equation. Okay, so this is what I can use to answer questions A through D from the text. Okay, if I'm given an X value, can I find the corresponding predicted Y value? Okay, so that's what I would use there. Okay, so let's take a look at the scatter plot. Okay, so if I move back over to graph, and I want to scroll down to scatter plot, I'm going to again tell it where my X variable is and my Y variable is. And I'm going to leave everything else defaulted for now, and then press on Compute. Okay, so looking at our scatter plot, we do see that we have an an overall positive linear trend for the data. It appears that all of the data points are falling in a linear manner that's increasing left to right. Okay, so that's consistent with what we got from our correlation coefficient from the original output. Now, one thing that StatCrunch will do, which is a very nice feature, most statistical software packages will do this, is we can, after determining that we do have a linear relationship, we can go ahead and use the regression equation, and we can appropriately overlay it on our scatter plot. Okay, so going back to graph, actually, you know, I can go ahead and go back to my graph here. If I click on options, I can edit my previous screen, okay, rather than having to go through it from scratch. Or you can go ahead and go through it from scratch. You'd have to tell it what the x variable is and the y variable is. Okay, so if we scroll down to overlay polynomial order, what this means is we want to overlay a polynomial function. Okay, and in this course, we are looking for a polynomial of degree 1. Okay, so we are overlaying a line over the scatter plot. Okay, so if I click on the down arrow and I select 1, and you'll notice that it's defaulting to the best fit. Okay, so that's going to be the regression equation that we found previously. Alternatively, if I had some other slope and intercept that I thought was a good fit, I could override that here. Okay, but we're going to go with the least squares fit that's outlined in the text. Okay, so I need to click on compute. And you'll see that the new graph now has the best fit regression line overlaid on the scatter plot. And if we hover our mouse over the line, you'll see that it pops up in the yellow box with the corresponding equation.